Hello, my beautiful students. I've had a few requests from people asking me to show you how to do the simplifying radicals, the dividing by radicals, all of that stuff that was the last section on your radicals homework. So I picked a couple of examples, 3 of them, this one, and this one are out of the homework, and then this is one I came up with on my own because I didn't see anything really quite like it on the homework. So we know that the number one rule when it comes to radicals is that you cannot have a radical in the denominator of a fraction. So this problem right here, the square root of 4 over 5 times the square root of 3, is violating that rule because we have the square root of 3 in the denominator. We can't have that, so we've got to get rid of it. Now what we do to get rid of it is we multiply times this radical that's in the denominator. But whatever we do on the bottom, we have to do on the top also. Now we know that a fraction that has the same thing on the top and bottom is just 1. It doesn't matter what's on the top and bottom. It could be the square root of 3 over 3. It could be 4 over 4. It could be x over x. If the same thing is top and bottom, then that means that it's just equal to 1. So all we've really done is multiply this times 1. But what this is going to allow us to do is to get rid of this radical that is clogging up our denominator. So across the top, I get the square root of 4 times the square root of 3. 4 times 3 is 12, but we've got to keep that square root symbol because square root of 12 is very different from 12. Now down here on the bottom, we are going to do 5 times the square root of 3 times the square root of 3. Well, we know that anytime you multiply 2 square roots of the same number, the radical symbol drops away, and what you're left with is just the number that's inside. So what we have here is 5 times 3 on the bottom. Now up here, we could have handled this one a little bit differently. We're actually going to break this back up into square root of 4 times the square root of 3 because oops, the square root of 4 is a perfect square. We can break that down to 2. Down here on the bottom, 5 times 3 is 15. So up here on the top, I've got my square root of 4. That's going to become just a whole number 2. And then the square root of 3 over here. And 15 on the bottom. All we've done is change this around. We've simplified it as much as possible by dividing out any numbers that can be reduced. And we've gotten this radical out of the denominator, which is something we absolutely cannot have. So this next example, the square root of 6 over the square root of 27. Well, before I start reducing anything, taking square roots or anything like that, I'm going to divide these out as best as I possibly can. I'm going to reduce these the same way I would reduce a regular fraction. I can divide 6 and 27 by the common factor of 3. Over here, I get the square root of 2, and on the bottom, I get the square root of 9. Well, the square root of 2, we're kind of getting used to the fact that that is the smallest square root we can deal with, and the square root of 9 is just a whole number 3. Okay, now what I have here in this example is the square root of 5 over the square root of 3. Well, just like the first example, I'm going to multiply by the square root of 3 over the square root of 3. So here I'm just multiplying by 1. That's all this is right here. But I'm going to change what my fraction looks like. So the square root of 5 times the square root of 3 is going to give me the square root of 15. And these 2 square roots of 3 on the bottom being multiplied are just going to give me 3. Now, it's very tempting to say, oh, well, 15 divided by 3, that's 5. The square root of 15 is a very different number from 15. 15 can be divided by 3. The square root of 15 cannot. So we have to be careful not to mix our whole numbers or our coefficients with our square roots. Okay, this last example, 4 over the square root of 28. Well, I can't have the square root of 28 in the denominator, but I know I can simplify that a little bit. I don't want to have to be multiplying by 28. I can make that much simpler than it already is. So I'm going to reduce that, and I'm going to say, okay, square root of 28 can be broken up into the square root of 4 times the square root of 7. So what I get is 4. The square root of 4 is 2 times the square root of 7. Well, 4 and 2 reduce, leaving me with 2 on the top and the square root of 7 on the bottom. Uh-oh, I can't have that. So I'm going to go down here, 2 square roots of 7, or 2 over the square root of 7, excuse me. So I've got to multiply by the square root of 7 and multiply by the square root of 7. So what I get here is 2 square roots of 7 on the top, and the square root of 7 times the square root of 7, which is just a plain old 7 on the bottom. And I can't reduce that any further. The square root of 7 up here on the top is as small as it will get, and I don't have any radicals in the denominator, so this is a perfectly acceptable answer to that problem. I hope this helps. Please remember that you can always ask me these questions in class, or come and hang out with me after school, and I'd be glad to help you one-on-one with them. Bye, guys.